Welcome to the course Business Analytics and Data Mining Modeling using R. So in the previous lecture we were discussing classification and regression trees. In particular we were doing an exercise in R using a particular data set, sit-down called data set that we have been using. So let's do few of the steps so that we are able to resume from the same point where we ended in the last lecture. So let's load this library. Let's import the data set quickly. Now in the last lecture we were able to create the model for this particular data set. So let's come to that point. Yes, so this is the part. So these were the variables. So let's reload this library rpart. So rpart is the function that we used last time. So let's build the model and the plot as well. So this was the plot that we had created last time, and we also talked about a much nicer version or pretty version of the plot or tree model. Then we talked about the node numbering and the requirement of node numbering if we want to snip off some particular part of the tree, right? So why we need this, it will be more clear as we go on, as we go along, discuss more in this particular lecture. So node numbering, as we talked about in the previous lecture, this nn argument we have to specify nn as true, so node number would be assigned, and then the character expansion, this parameter is also can be used. So once node numbering is done, you can see in the plots, so you can see in this is the full grown tree using the full data set that we have, and node numbering has also been done. So in the previous lecture we had done first split where we just wanted to have the nodes which we nodes till the point of first split, right? So this is the first split. So we would like to have the nodes just one node and then the other terminal nodes, right? So in that case as we talked about that we have to from these node numbers we have to see if we want to keep these three nodes. To remodify our example, we want to just keep these three nodes, this first decision node, then this terminal node, and then other one, this one also be decision node and followed by terminal nodes. So we want to keep the these two decision nodes and the corresponding terminal nodes as well. Then we will have to snip off nodes starting from here 6, 7. We talked about the unique node numbering scheme that we have in tree models in general or in tree algorithms also. So so we have to specify. So this is the function snip.rpart. So snip.rpart function will allow us to remove some of the unwanted nodes. So we just want to focus on the first level or first few nodes. Then we can remove this the other nodes using this snip.rpart function. So first argument is, as we talked about, is going to be the model, that is mod, that this object rpart object, and then the second argument is where we specify the node numbers which we want to get rid of. So you can see 6 and 7, 12 and 13, 24 and 25. So these are the node numbers that we want to get rid of. So we can run this particular function, and you would see that new model, the subtree model has been saved in mod sub, and now we can print this particular tree model. Now you can see this is the new model, rather snipped off version of the same model, right? So you can see two decision nodes here and the corresponding terminal nodes as well. We want to keep just one node, so the first split that we talked about, so we can remove this one as well. So then we will end up with the just one node. So let's say in the previous this was the full tree, right. So in this full tree, so if we will have to remove 3 as well. So if we put 3 here, we also pass on 3 node number 3 also as the argument here, and then we do our sniping, then this will also be removed, and the new plot would have just one root node. You would see just one decision node, that is the root node, and that is also indicative of the first split, and the others, right, they would be, now as you can see, these are the terminal nodes where we get the final classification. So in this fashion, depending on the, because as we talked about, the full grown tree could be large, and if the data set is quite large, and then there are more number of variables, as we will see in through one more exercise, one more example data set, that the whole full grown tree could be quite messy and difficult to understand. So therefore this exercise will help us in just displaying or plotting the first few labels, so that we can look at some of the most important variables that are being used to create splits or to create partition. So similarly, if we wanted to have 3 splits, so as we talked about, we can go back to the full grown tree. So this was the tree. So in this, if we want to have just 3 splits, so split 1, then 2 and 3. So therefore we will have to remove the other nodes, right. So let's go back. So other nodes would be 12 and 13 and 24, 25. So we can get rid of these nodes, right, 12, 13. So appropriately mentioned here. So we can get new subtree, and then we can print it. Now you can see in this new one, we have just 1, 2 and 3 splits, and the corresponding terminal nodes as well. So in this fashion, depending on the labels, we can snip the tree, full grown tree, and the importance of this particular process we will realize when we discuss further. If you are interested in different attributes that this R-part object, R-part model object actually is carrying, so that we can do using attributes command. So this particular is generic command applicable to other techniques as well. So different models that we have been building in previous lectures while discussing techniques. So there also the attributes function can also be used to find out the different information, different results and information that is stored in the mod object. So this is R-part object, and you can see information that is there. So more details on what kind of what these frame is about, what these other variables are about, you can always go to the help section, and you can always find out more about the R-part object. And if you look at the R-part object in the help section, then you would see frame, first value frame, you would see then second value. So the mode frame is quite big, it's actually a data frame, so containing lots of information, then where, call, and other attributes that you can see here, they can be easily seen and understood. Summary mod function is also there, so we are interested in looking at the summary. What summary function, again generic function, what it contains is the call, the CP table, which we will discuss again later in the discussion also. But since we are in the rpart.object page, you can see that there is another description for CP table, a matrix of information on the optimal prunings based on a complexity parameter. So that is generally displayed in CP table. Let me also tell you that R-part control function, specific function that we talked about in the previous lecture, right. So we open the page for R-part control, you would see there is one specific argument for xval, that is number of cross validation. So the R part function that we have in this particular package, it also does some cross validation. So some of the, as we talked about in the previous lecture, that some of the observations are reserved for cross validation within the training partition, within the data that is supplied to our part function, and that is then later on used to produce the CP table and other information. So we will discuss them as we go along. So coming back to the summary output, you would see that later on you would see the variable importance is also mentioned here. So classification and regression tree, one aspect of this particular technique is it can also serve as a variable selection technique or dimension reduction technique. So some of them we discussed before. For example, we talked we have already discussed dimension reduction technique and variable regression based variable selection approaches, right. So the classification and regression tree is also one of those techniques which helps us in terms of identifying the more important variables, more important predictors, right. So in this case you can see variable importance is also part of the output. Annual income is 77% importance, and household area is remaining 23%. If we had more number of variables, we would have got much larger, much bigger list. So in terms of from this we can say, in terms of identifying, in terms of classifying the sedan car ownership, annual income is more important than household area. The same thing you would see is also reflected in the plots as well. You can see the first split is based on annual income. Then in the summary output that we were discussing, right. So for every node, some information about the split that has been performed on that node, and more information on that node also is always going to be available in the summary output. So you can see node number 1, 20 observations. So you can see in the let's go back to the full plot as well. So this was the full plot. So you can see 20 observation in the root node, all 20, 10 and 10 class counts were also 10 and 10. You would see the expected loss that this value is also there, right. How many observation in the left side, how many observation in the right side, left child or right child. So different terminologies are there. So you can see 6 observation in this particular node. Let's zoom in. So you can see in the left child, this is also terminal node, and you can see 6 observations here, and you would see that right son it has 14 observations, right. Node number 3. So you can see node number 3 and 14 observation. We will have to combine all these 4, 1, 5, 7 and 7, 14. So in this right child is actually quite in its own, it's a subtree. So within this subtree you can see 14 observations are there, 6 and 14. So that was the partition at root node. So split is done on based on this particular classification rule. So that also you can see the improvement value is also there. Now if we scroll down further, we'll also see that other nodes, node number 2, node number 3, right. So there also 6 observations, 14 observations. This was terminal node. So there this was no split was done here. As you can see the information there. In the node number 3, the split was done here. As you can see the split rule is, classification rule is also mentioned, and the left hand number of observations, right hand. So in this fashion we can always find out the details about the splits that have been performed by R part function. Now with this let's start our let's discuss further using another example, that is a bigger, larger data set having more than having around 5,000 observations. So let's look at this particular data set. This is the promotion offering data set. So 3 specific variable in this we had used in a previous lecture, where we had income, spending, and third variable promo offer. So where we based on the income and spending we used the this particular for classification or other visual techniques we use these 3 variables. Now this is full data set where we have information on income, is spending, and the promotion offer is our outcome variable of interest, and then we have information on age, PIN code, experience, family size, education, and then online activity status. So this is this particular information is about a particular firm whether finding out trying to build a classifier whether a particular customer is going to respond to their promotional offer or not. So the promotional offer, that particular column, that particular variable being the outcome variable, and using the other information, other predictors, other variables that we have in the data set, they will play the role of predictors, income, spending, age, PIN code, and others. So using these variables, we will try to classify a model where we will build a classifier where we would like to classify whether a particular observation, whether a particular customer is going to respond to the promotional offer or not. So other variables, age is again age of the customer, the responder. PIN code is the location of that particular customer. Experience is the actually the professional experience that of that particular customer. Family size of that customer, and then we have education, whether he is 12th pass, HSC, or graduate or postgraduate. So we have some information about the education, and then the online activity. So whether the customer is online active or not. So 1 representing, 1 indicating that the customer is online active, and 0 indicating that the customer is not active online. So with this information, we would like to build a classifier to predict the whether the customer is going to accept the promotional offer or not. So with this background, let's come back to our studio, and we will start our classification tree model. So first let's import this particular data set. Since there are 5000 observations, so our build takes slight bit more time to import this particular file. So as we have talked about that once the data is imported, it is actually stored in the memory. So therefore it takes a bit more time to bring all the observation into memory, and therefore now this is done. So you can see in the environment section df1 data frame 1 5000 observations of 9 variables. So let's remove any columns if there are any. So there was none. So first 20 observation, if you want to have a look again, you can do this using subset using brackets. So these are the the data has been correctly imported in the R environment, as you can see using first 20 observation. So all the variables are there. Now let's look at the structure of this particular data set. So you can see income is numeric, then spending is also numeric, then promotional offer is again is shown as numeric. So therefore we would be required to make it a factor variable, right, because there are just 2 values, 0 or 1, 1 meaning acceptance and 0 means rejection of the promotional offer. Then we have age, which is numeric, so no problem. PIN code, so again this is also one variable that we talked about in our starting lectures when we discussed more about the categorical variables, that PIN code or zip code, these codes are essentially categorical variable. However, it is quite difficult to incorporate these variables in the models because for different customers, for different individuals, the PIN codes can differ, and there can be too many number of PIN codes, and that would add to the dimensions or number of variables that we include in our model. So the dimensionality could be a problem, right, the curse of dimensionality because of the categorical variable having so many categories, because each PIN code is going to represent one particular category. So if there are 5000 observation and they are covering 250 locations, so we will end up with a categorical variable with 250 labels. So that can create problems in our modeling, too many predictors, too many dimensions. And so how do we overcome this situation? One solution could be we can we can model this particular variable as a numeric variable, right? Because the location can also be though even though this is numeric code, but because the number of categories are many, and location can also be associated with the latitude, longitude, and therefore latitude and longitude which are numeric in nature, and these codes in that sense can represent latitude and longitude, because generally when these codes are assigned, so there is some method, there is some some process that is adopted to assign these codes. So therefore they might in a way represent the latitude, longitude, and they might in a sense might be the ordinal variable. So therefore if there are too many categories, they can also be treated as a numeric variable. However, in this particular exercise that we are going to perform, we will treat them as categorical variable, and we will see how we are able to reduce a large number of categories into few groups, few number of categories, and then use them as a factor variable. So we will see that. Then the next variable is experience, which is numeric, which is just fine. Family size numeric, which is also fine. Education is factor, 3 levels, so appropriately mentioned here, so no need to change. Then online, so this is mentioned as numeric, but we will have to change it because it is factor variable with 2 categories, active or non-active. So let us start with our pin code variable. So what we plan to do is grouping. We will try to group the categories of pin code. So how do we go about grouping these categories? As you can see in this our classification task, we are trying to classify the value of we are trying to classify or predict the class of promotional offer variable, that outcome variable of interest, and therefore with respect to keeping in mind this being the supervised approach, supervised algorithm. So everything is driven by the outcome variable. So essentially the whole focus is in decreasing the overall error for classification of this particular variable, promotional offer, and therefore the pin codes they can be grouped with respect to this particular variable, promotional offer. So what we can actually do is the areas which have similar sort of acceptance rate or similar sort of rejection rate, they can actually be grouped together, right? So because the task is prediction of this particular variable, promotional offer. So in terms of the predictability or importance of this particular variable pin code, the areas or pin code or cities or towns having similar acceptance rate level can be grouped, and or having similar rejection levels can be grouped together, because having them separately as individual category and grouping them and grouping the locations with similar success rate won't impact much to the model, rather will end up with fewer number of dimensions. So we would be able to reduce the dimensionality by clubbing the similar types of locations where the acceptance or rejection rate is similar. So this kind of exercise we had also done in visualization technique, but that was limited to the generating bar plot. So we will go through in an actual modeling exercise. So first we would like to look at the number of categories that we will have to handle. So pin code is the variable. You can see as dot factor is being used to coerce it into a factor variable, and then table function is being used so that we are able to understand the number of categories that are going to be there and the frequency of those categories as well. And so let's look at this. So T pin. So let's we are interested in looking at the actual values, so we can do this. So you can see for each of these pin codes you can also see the frequency. So for example, the pin code 110001, this is 54 times it has appeared in the data set. The other pin codes also the similar numbers are being displayed there, right? So the frequency for different pin codes we can easily see. Now the pin names for these pin codes we can easily extract. So if we want to extract the pin codes, and so we can do this using dim name dimension names function, dim names function, and we can pass on this table object here, tpin, and the first first element. So this is actually a list, so first element of which is going to give us the pin names. So we can store this here so that we can later on use it when we generate the bar plot or for other things. So what we are going to do, as we talked about, because we want to group these categories as per their success rate, as per their acceptance rate or rejection rate of the promotional offer. So we will have to count for each of these pin codes. We will have to count so that we can compute the acceptance or rejection proportion or rate, right? So let's initialize this variable count pin code, c underscore pin code. So once this is initialized, you can see I am running a loop here. So for all the pin names which we have just computed, for all of those pin names we are going to run this loop, and in this loop you can see within this combine function the pin code, and we are converting it into a character vector so that it could be compared with x, which is character vector, because pin names is the character vector here in this case. Same thing you can also immediately understand by looking at the environment section. You can see pin names is stored as character vector. So therefore pin code, which is essentially the numeric vector, the way it is stored right now, so we'll convert it into this so that comparison could be performed. And once for a particular value x, that particular pin code, then we will look at whether how many of the observation, for example, let's say pin code this 110088, so 54 times it is appearing in the data set. So out of those 54 times, how many times the customer has accepted the promotional offer. So we would like to count we would like to count that the number of acceptance, right? So in this fashion, so once all the observations with that particular pin code are selected, and within that the promotional offer, when that promotional offer was accepted, so those observations will get the indices of those observations using the which function, and then length, when we apply the length function on those that indices vector, will get the count. So for each pin code, the success count, the acceptance count, number of acceptance, that will get through this code, and then that is going to be stored here in this particular c pin code variable. So what is going to happen is, for each of the pin codes which are there in pin names, right? So for each of them, this kind of count of acceptance would be performed using this particular for loop. So let's execute this code. Now you would see in the environment section, we have created c underscore pin code variable here. This is an integer variable. All the values that are there, they are counts actually. So those all of them are integers. So you can see some of the values you can see here in the environment section itself, right? See, for different so 96 pin codes were there, right? So for all those 96 pin codes, we have the count of success. You can see in pin names, the character vector that we had created, 96 pin names were there. So 96 pin codes were there, and for all those 96 pin codes, 96 locations, we have been able to count the number of observations, which actually number of customer who actually accepted the promotional offer. So once we have this information, let's look at the range before we generate the plot. So you can see the maximum number of acceptance is 12, right, and the minimum is 0. So with this information, when we have this information, we can actually generate a bar plot and analyze visually what has been the acceptance and rejection proportion and other things. So let's create this bar plot. You can see the limits on y-axis are appropriately specified, 0 to 13. So the range is within this limit. Let's generate this plot. So first we need to correct the graphics setting. Now so again let's generate this plot. Now we get the plot in the desired format. So you can see on the y-axis we have number of promotional offers accepted, so this is 0 to 12, and on the x-axis as you can see the different pin codes have been mentioned here. So all the pin codes that we have, 96 of them, so all the pin codes for different pin code we can see the bars, right. So from here we can further analyze and identify which of the groups can be clubbed and whether there are any groups by looking at this plot which can actually be clubbed or grouped. So at this point we will stop here and we will continue our discussion on the classification regression trees. Thank you.